So funny.
I don't know about you guys, but I need a vacation.
Oh, tomorrow.
Yeah, well, here's the thing. So I feel like taking a vacation. I'm going to take a trip around the world for 30 days. How about that? Pretty
You
reasonable,
take a
right?
trip around
Oh
the
no, here we go. I know what she's doing.
Yeah.
Oh no, that's not related. That's not, she's not talking about fun. Babysitter.
I guess if I see
Okay, so I'm going to be gone for 30 days. I need to hire a babysitter because if I want vacation, they're not going.
You're not ready.
Well, here's the thing. Before I hire you, you can talk about it.
No, we haven't.
Before I hire you, I'm going to give you 2 options for payment. Now, I do not want your outside opinion to be loud, to be vocal. I want an opinion in your head first. Do not say out loud your opinion. Think to yourself. Do some research for yourself. I got 2 plans. First plan, I will give you 1 penny for day 1. And then I will double that amount for each day. So like day 2 would be what? 2 pennies, and day 3 would be 4 pennies. Okay. Or B, how much you want to earn a day? $100? Or 100,000? Okay, we'll do 100,000. Oh, we'll do 100,000. I think that's fair. I mean, if you put up money, so. Okay, so to yourself, decide which plan you would go with. How long is this trip? 30 days? 30 days? Gotta go around the world. Long time.
Can we actually do this though?
Can you actually find how much you'll make? Then you can't, actually.
Wait a minute. Hey, oh my god, that hurts right.
Why? You're just timesing it by 2. And you have a calculator.
Oh, I know.
I was trying to get on the open notes, so he got I failed.
Did you make your choice? Did you make your choice? Did you make your choice? Well, you're only going to know if there's a trick if you actually calculate it. Otherwise, you're not going to know if there's a trick.
Oh, yeah.
To yourself. To yourself. That might be helpful if you knew how much you'd make for 30 total days. Careful, please. All right, let's see. How much are you going to make for $100,000 per day for 30 days? Now let's try 3 million. 100,000?
Yeah.
That
That do work though. How much are you going to make for this one?
Like 10. I got 10.
How'd you do that?
What?
How'd you get that 10?
I just sat here.
And you were just calculating the whole time? That's really, that was good. That was really good.
I had a .01 and hit times 2 30 times.
That's what
And then did you add them up?
I didn't add them up. Yeah, now you can. Okay, yes.
Oh,
That'd be one day.
no. This, I'm putting up, I'm not finished, but I'm putting up the total.
That's why.
No, you, I think found it for 31 days.
Oh.
Oh, that's it's too
I'm the same. I'm the same. Except I'm 2.24.
Yeah, that's pretty crazy. No, but that's for 31 days.
Okay, I'm sorry, my mind is so long.
That's a 30%. Just the messenger.
Shut off that money.
Okay, so anyway, so this was very deceiving because this was a very large amount, but it was a constant amount. It wasn't changing. This one was a very small amount, but we were doubling it each time. It's very deceiving. This is called exponential growth. Have you ever heard something that is like grows exponentially? That's what fingers crossed, that might be exponential decay. So growth is exponential growth where it starts out slow and then it just like explodes. And exponential decay starts out with a large amount and it goes down and then it goes down. There's one more example that I have for you. So it is my daughter's birthday this week. And to celebrate her birthday, about 2 weeks ago, I made a thing of brownies. Because really, I'm the one that did all the work. For real. Okay. On the first day that I had the brownies, I don't want to eat too many, so I only ate half the pan. I didn't want to eat the whole thing, so I ate half of it. And then the next day, I ate half of what was left over. And then on the next day, I ate half of what was left over. And then on the next day, so I don't want to eat the whole thing. You don't want to be like the person that eats the last piece. You just eat half. You just eat half of what's there, so you're not that person that eats the last piece. Let ever eat all. Right.
No.
I can't multiply by a half and end up with 0. It's impossible. That will never happen. It will never equal 0. This is an example of exponential growth where I start with the whole pan, and then I have half of that, 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 and then I have half and half, but I'm never going to equal 0. It's never going to equal 0. So this is going to be a nice curve that starts out, it goes down really fast, and it just keeps getting smaller, but it never equals 0. Today is all about exponential growth and decay. You have the notes, and the first couple pages are all just information. This is going to talk about the exponential growth and decay equation, which is up there. I'm just rewriting it. It's seriously just right up there. B is called the growth factor or the decay factor. If B is greater than 1, it's growth. If B is between 0 and 1, it's decay. So B is greater than 1, it's growth. If it's between 0 and 1, it's decay. You should have done this in Algebra 1. But what's going to be new about this from Algebra 1 is we are going to do the inverse of this. And it's going to be completely brand new. You've never done it before. Yep. But for some reason, as soon as we give it a name, it gets confusing. So if you are really doing your homework leading up to that, it's not going to be hard. And then here's a picture of an exponential growth equation. And there's a new vocabulary word we haven't used in here yet, and it's asymptote. Asymptote. Asymptote is an imaginary, it's a line that's there, but it's not there. It's not part of the graph, but it's a line. And so far, until we do transformations, our asymptote is going to be at y equals 0. This asymptote comes because with the pan of brownies, it can never equal 0. It's just going to get smaller and smaller and closer to 0, but like if I half the brownies every time, it'll never equal 0. So that's where this asymptote comes from. Asymptote, asymptote. Here's the domain of exponential growth. By the way, exponential growth left to right is going up. Here's the domain, all real numbers. The range is y is greater than 0. See, it does not equal 0. Greater than 0. And then there's a picture for decay. Exponential decay, as you go left to right, is going down. But it never equals 0. So there's an asymptote at y equals 0. An asymptote at y equals 0. That's decay. So today we're going to learn the basic growth and decay pictures, and eventually we will transform them. And then we'll do the inverses with them. And then we'll transform the inverses of them. So we'll start with tell whether it's exponential growth or exponential decay. Then we're going to graph the function and solve the information. So y equals 2 to the x. This is the form of y equals a times b to the x. So y equals 2 to the x. 2 is the b. So in this equation, b is greater than 1. What does that tell me? Exponential growth. So we graph this picture, it should be growing left to right the way we read left to right. We're going to have key points. And that's just like with our parent functions where you have those few x's and y's you memorize for all of them before you do transformations. There's going to only be 2. X is 0, x is 1. You're going to plug in those x's into the equation because these equations are slightly different. They're not always going to be the same y's. Plug in 0, 2 to the 0, what do you get? Plug it in your calculator and tell me that's true. Remember, I told you you can never get 0. 2 to the 0. In the last chapter, we went over exponential rules that say anything to the 0 power is 1. And then we plug in 1 for our x, and we get 2. We go and we plot those. 0, 1, 1, 2. And until you've done enough of these to know what the picture looks like, you might want a couple extra points. So I might put in 2 more points, but these are the key points. Those 2 are the key points. But we might do some extra. So let's do when x is 2. Plug in 2, what do you get? 4. Okay, that one's an easy one to graph. 2, 4. What if x is negative 1? That's going to be 2 to the negative 1, and we have studied negative exponents. What does the negative exponent do? Reciprocate. So what's the reciprocal of 2? 1/2. So our order pair is negative 1, 1/2. You see that growth curve being formed. If you want to find any more points, you can. My asymptotes, for now, y equals 0 until we start doing transformations with these. I'm going to graph it at y equals 0. And then when I connect it, my graph is going to follow through these points, but then as it gets closer and closer to the asymptote, it just gets closer to it, it never crosses through it. It gets closer to it, but doesn't cross through it. Gets closer to it, but doesn't cross through it. What happens with the asymptote? It gets closer to it, but it doesn't cross through it. Domain. All real numbers, range. Y is greater than 0. Next. What did you say? Well, we're not doing transformations today, so that would be pretty cool. Not today. Okay, so my next one is y equals 1/2 to the x. Is this growth or decay? B is a half. That is between 0 and 1. That is exponential decay. That tells me my graph, as I graph it left to right, will be going down. We'll find some key points. What x's should I use? 0, 1. I can use more than that, but those are the ones I should use. So I'll plug in 0. Half to the 0 is 1. Anything with 0 power is 1. Then I plug in 1. I'm going to half. So I go graph those. 0, 1, 1, half. I don't know if that's enough information to see my graph very well. What happens if I plug in 2, though? I get a half squared. I get a half times a half. Which is a 4th. That's not even getting better for me to graph. Maybe I should plug in something the other direction. But negative 1. What's a half to the negative 1? Reciprocate. 2. What is a half to the negative 2? Reciprocate and square it. 4. So negative 2 is 4. That gives me a little bit more points. But my key points are just 0, 1, and 1/2. Asymptote. Y equals 0 until we start doing, what are those called? Transformations. So when I graph it, I'm going to connect those points, and then on the asymptote side, get close to it, but I'm not passing through it. Domain, all real numbers, range, y is greater than 0. What could possibly move the asymptote? Think about transformations. Here's the asymptote. What could possibly move it? Not shrink.
Going down.
Translation. What about translation? That's going to move your asymptote. What if I do a translation left or right? It's still. So if we have translation up or down, that's going to move R. But you won't have any today. But we want to start thinking about that, because you will. Okay, next one. You try. Also, remember, we won't have it either, even if we're here. Well, if we're here, then I won't have it either. But we're not having one. If we're not here. But if we have logins this week, then I'm not going to see one. But regardless, you can see what the next groups are. They're in the packet after the graphs, but we're only doing graphs today. All right, try this on your own, please, so I can see that you're getting it. I need to see if you're getting it. For the first power. Why do you need that? It's always.
Like 2 plus 2.
You know how you get so interested?
Right. 1 plus 1 can be 2.
Double check one.
Never hurts, right?
Yeah, it does not hurt as long as you've done it first. But if you use that as your go-to when I say no calculator on the test, you're like, what do I do now? Do you get growth or decay? Yes, it's growth. Because this number is bigger than 1. Key points? 0, 1, and 1, 4, and then you might find others. Asymptote, y equals 0. Domain, range, done. Okay. Like if you put in 3,
Yeah.
actually 4. No, if you put in 2. I lied. If you put in 2, 15. Yeah. It's like way up there for 2. Okay. So you might need to find another point just kind of fix your graph until you understand what they look like. Okay, how about this one? Next. You try. Next. Oh, I skipped one, didn't I? Sorry. You try. Zayna, do it. Where's the rest of this graph? Do it. It's got to be there. I can tell when you guys graph this stuff who uses a calculator and who doesn't. A lot of times by the way you do your graph. If you know what the graph's supposed to look like, you're not going to use a calculator. You can check it on the calculator, but the calculator sometimes doesn't graph it as accurate as possible. Remember when we made those circles and it didn't connect? Kind of that same thing. Yeah. It's kind of the same issue with the calculator with this one too. This is exponential growth or decay. What's 2/3? Decay. Decay? We plug in 0 and we plug in 1, so you get 1 and then 2/3. I feel like I might need another ordered pair or two for this one. The assignment is practice A from the worksheet, but just be careful because practice A is only the front and back first page, then it says practice B attached to it. That's not today's assignment. Okay? If you try to do practice B, you're going to read it and be like, whenever that may be. I guess it will be Thursday. You're right. It keeps going down. Last I saw was like 1-3. Earlier this week was like 5. Now it's like 1. Not here.
5 days a week.
We're gonna have to go through this whole thing again. Okay, so look at her paper.
No,
Yeah, okay, look.